Okay, circle theorems. I'm going to talk through them here, but I'm not going to explain each circle theorem too thoroughly or how it works. If you don't know them, I recommend the Maths Watch videos or going on to My Maths. But looking at this one, straight away, I need to find U and V. And it tells me DA is a straight line. I don't necessarily know what to do to start with, so always what I do is if there's a really obvious one, I just draw it on my test paper. That is going to be 180 degrees. Angles on a straight line are 180, so that's going to have to be 100. Now, hopefully you'd be able to spot that this here that I'm creating round, it's a quadrilateral in a circle with all four of its vertices on the circle. That means it's a cyclic quadrilateral. The thing about cyclic quadrilaterals is that the angles opposite always sum to 180. So U is going to be equal to 180, take away the angle opposite it, 100, which is going to be 80. Now I don't need that working for this, I can see it's only worth 2 marks, but I always find it useful to put down anyway. Now I've got that, I'm going to write that on there, because now I've got that helps me forget it being U. It's not going to be U, it's just 80. And this is where you've got to remember another one, which is that there, D to C, these two blue ones, DC, BMM, that gives me 80 degrees. From those 2 points there are 2 lines going into the middle. I'm going to make them green. And it's an example where the angle at the centre from those green ones has to be twice the angle at the outside. So V has to be twice the angle at the outside, so 80 multiplied by 2, which is 160. Okay, part A done. We've done cyclic quadrilaterals and the angle at the centre. The length of perpendicular for O to GH. So just reading this, it tells us what the radius is, and it's after a perpendicular from O to GH. So I start straight away by drawing on that perpendicular of which it talks. So it goes through there. Now I know it is 8 centimetres long. And what's not necessarily obvious is that these will probably help a lot, to start with as well. That's a bit better. That's a bit better. So generally speaking, if you can somehow make a triangle, it's almost always a good idea. I mean, not always, but almost always. So I'm going to call, well, actually we know OH, that's a radius, so that's going to be 8. That's a radius. Oh, that's a radius. That's not writing. That's a radius there. That's going to be 8. Also, we know GH is a chord of length 10 centimetres, and I know that chord will bisect a radius, or when a chord bisects a radius, it's at a right angle. So that must be the bisector. So that length must be 5 there. And that length must be 5 there. The key part is this bit of the line I'm going to label blue, so that's what we're after. Now, I know I can work that out now using Pythagoras theorem, using a right-angled triangle. So we'll call it x, so x squared has to be equal, sorry, this is one of the smaller sides, isn't it? So x squared plus 5 squared has to be equal to the hypotenuse squared, which is 8 squared. I can do that using either of the two triangles here. So I know that x squared is equal to 64 take 25. So x is going to be equal to the square root of 39. Which, if I plug it into a calculator, gives me 6.24 centimetres. So the key to this one is remembering if you bisect a chord, then it's radius, and also try and make triangles wherever you can. Okay, on to part C. There's quite a lot going on in here, and I'll try and describe it. So First off, we can't actually work out anything straight away, but what I can see is some circle theorems. So that angle I'm trying to sort of colour in yellow here, MNL, let's call it, and MKL have to be equal. They're angles in the same segment, so those two angles have to be equal. I don't know what they are, I just know they are. It's a circle theorem question, so that's probably going to be useful. And by the same logic, on the other side, these are angles in the same segment, NMK and NLK, both start at the same point, both go to the circumference, so those two angles must be equal. Which finally, looking at these two here, these are opposite angles, so those two blue ones must be equal, which means that MNX, that triangle, is similar to KLX. That is important. Similarity in maths helps us load, so it's essentially become a ratio question. It's asking us to work out MN. I wanted to do that in a different colour. It's asking us to work out that length there. So I know that the length, where are we? So I know that the smaller length, the one in between, so NX, that 2.5, if I divide that by what I'm after, NM, that ratio is going to be the same as the smaller side on the larger triangle, which is 4.8, over the other one opposite, 9.7. Doing a bit of rearranging there. I'm just going to race through to the end of that one. I'm sure you can do it yourself. I hope so anyway. You get 2.5 multiplied by 9.7 over 4.8, and that gives you the answer of 5.05, I believe. There are other ways of doing that, working out the scale factor. That's normally the way I do it, to be honest, work out what the scale factor is. It's a little bit less than 2. You could be more precise by dividing it to get from that triangle there, 2.5 to 4.8. Little bit less than 2 you're multiplying by. And so then you could work the other way around and divide this larger length by a little bit less than 2 there. But again, that's an odd one. You don't necessarily think of using similar triangles there, but there's obviously a couple of things you know are the same, even if you don't know anything about them. Which brings us on to the final of the 4 circle theorem questions. So I've given us a bit of a head start on this one. It's the same as the last one. They warmed it up for us. They share 3 pairs of angles, which mean that those 2 triangles are also similar, and we can very quickly work out the linear scale factor of them, because the side between the red and the blue on the smaller triangle is x, and the side between the red and the blue on the larger triangle is 2x. So the linear scale factor is going to be quite simply 4. Telling us the area scale factor, which is going to be that squared. Sorry, the linear scale factor is 2, I meant to say a minute ago. The area scale factor is 4. I was jumping the gun. So if you double the length, it means the area is going to be 4 times as much. We know that based on those circle theorems, leading us to knowing they're similar. So if they're similar, then twice the length, 4 times the area. Now that is important because we're given some information about the area. I know that the smaller one, which is YRS, if I multiply that by 4, I get the same as the larger one. Let's set up that equation. So 4 lots of this monstrosity, 5012x, times by x minus, oh, that's very poor minus there, apologies again for my stylus use. It's going to be x plus 1. I'm going to have to solve this, so probably easy if I just start by multiplying out anything I can. So let's just multiply 4 by 5/12 first. That gives me 5 over 3 x minus 1. It's going to be x squared plus x. That's what happens if I multiply that out. Now, building on from there, I don't like that 3 being over here, so I'm going to just multiply everything by 3 quickly. You can obviously do this any way you so choose, as long as you're not making mistakes. That gives me 3x squared plus 3x. Now I can multiply out my left hand side, so I get 5x squared minus 5x is the same as 3x squared plus 3x. I think I'm just going to move everything on the right over to left. I've obviously got a quadratic, so the first thing to do with any quadratic is make it equal to 0, then we can think about how we're going to solve it. So 5x squared take 3x squared gives me 2x squared. Negative 5x subtract 3x would give me negative 8x. So now I can simplify it even more by dividing by 2. So I get x squared minus 4x is 0. I can then solve this through factorising, which is quite nice. I get x minus 4 is 0, so either this x here is going to be 0, or this part here is going to be 0, so x minus 4 equals 0. That would mean x would have to be 4. So using that, I get, this isn't a solution. Obviously x can't be 0, because x is a length. So let's come off the page there, but that's a length there. Right, so that means my answer must be x is equal to 4. I like it when you get such long work and you get a nice round answer at the end.